All right, so now we're going to just apply these converse statements, some basic problems, and determine, are these lines parallel? So is line L parallel to line M? Well, we have a pair of corresponding angles. We're going to write this. We're going to write no. Corresponding angles ain't congruent. All right, so that's how we tell. This is very simple, but we have two angles, this angle and this angle. They meet the qualification for corresponding angles. They are not congruent, so we are confident that the lines aren't parallel. At some point in time, they will intersect. All right, what about this case right here? Well, we got to do a little bit of thinking. All right, several ways to do it. Let's do it this way. Okay, 71 and 109, no defined relationship. We can say consecutive exterior angles, but we don't have that for some reason. All right, the measure of angle 1 plus 109, it's a linear, we have a linear pair going on right here, linear pair. So the measure of angle 1 plus 109 is 180. So measure of angle 1 equals 71 degrees. So is line L parallel to line M? The answer is yes. Corresponding angles, we can call it the cap converse. Actually, let's write it out for now. Corresponding angle postulate. You guys can write cap if you want. Converse is true. All right, we had corresponding angles that were congruent, so these lines must be parallel. All right, is line L parallel to line M? In this case, nah, bro. All right, consecutive interior angles aren't supplementary. All right, 130 plus 67, contrary to popular belief, it does not equal 180 degrees. So that's how we know that. Pretty cool. All right. So that's some basic applications of the converse of the theorems that we just talked about. All right, some logic problems right here. I really like these logic problems. In the diagram on the right, which lines must be parallel if the measure of angle 3 plus the measure of angle 6 equals 180 degrees? So again, we always have to isolate what we're talking about. We got 3, we got 6. All right, well, they're both hugging this line right here. Let's even do this. All right, I can even extend this line. I can even extend this line. All right. So if they add up to 180, what lines must be parallel? So when naming these lines, it's going to be this line right here and this line, these green lines. You can name them several ways. I can say AC is parallel to DE, okay? Or, I mean, it's the same line, this is the same answer. You could say CB, because you remember when we do lines, we only need 2 points, and the order doesn't matter. All right, so you could say AC is parallel to DE, or CB is parallel to ED. And which theorem or converse would be used? It'd be the consecutive interior angles converse. Why? Converse, proving lines parallel. Okay, theorems prove angle relationships, converse proves lines are parallel. All right, which lines must be parallel if measure of angle 2 equals the measure of angle 4? Again, let's emphasize what's exactly going on. All right, so we have 2, we have 4, transversal, Okay, now we're focusing on this orange stuff, all right? Since 2 is congruent to 4, we know that BD is going to be parallel to CF, all right? These lines are going to be parallel. And why? The corresponding angles postulate converse. Okay. Let's use brown this time. 6 and 9 are equal. All right, so we're looking at number C now. Number C says, which lines must be parallel if the measure of angle 6 equals the measure of angle 9? Measure of angle 6, measure of angle 9. All right, so let's emphasize these lines, the brown ones this time. Well, again, it's going to look very similar answer because we still have BD and CF. So it's the same answer as above, but for different reasons. Why? What's the relationship with 6 and 9? Alternate interior angle converse. Okay, and which lines must be parallel if the measure of angle 9 equals the measure of angle 4? Okay, so let's emphasize what we got going on. Measure of angle 9, measure of angle 4. They're both hugging this line right here. Got this line, oops, a whole bunch of junk going on. My triangle's looking very pretty over here now. All right. Which lines must be parallel? Well, DE must be parallel to AC. Why? What's the relationship 9 and 4? They're in the same relative position. They're both on the top right in their little cluster of angles. So it'd be cap converse. Okay. And in this unit, we do got proofs still scattered throughout. A little bit of proofs. We'll knock out this proof and then we'll save the rest of the proofs for the video or for the next video. All right. So we got the parallel transitivity theorem in a plane. If two lines are parallel to the same line, then the two lines are parallel to each other. Cool. All right. So that kind of sounds obvious. If A is parallel to B, B is parallel to C, well, A and C must be parallel to each other if they lie on the same plane. All right. So again, good habit to draw in our picture. A is parallel to B, B is parallel to C, so they must be parallel to each other. Let me actually do the different colors just for fun. Okay, and our first reason is given. All right. So I really like this proof because we get to go back and forth between our theorems or postulates or converses, whatever. Okay. So we're saying 1 is congruent to 2 in statement number 2. Well, we know A and B are parallel. So since the lines are parallel, we know angle 1 is congruent to angle 2 by the corresponding angles postulate. Okay. Now, we know B and C are parallel. So what's the relationship with 2 and 3? Well, they're alternate exterior angles. So we know that they're congruent by the alternate exterior angles theorem, right? Corresponding angles is a postulate we just accepted as fact, but remember that alternate exterior angles theorem we actually proved to be true. And it's a theorem because stating, this is a side note, or excuse me, stating angles are congruent. Little side note. All right. So next, what do I do from here? So remember, we can tell stuff by looking at the picture, but sometimes I need to derive new statements by looking at previous statements. I know that angle 1 is congruent to angle 3. How do I know that? Well, I'm really smart. But why else would I know that? Angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. So I know that angle 1 and 3 are congruent because they're both congruent to angle 2 by transitive. When two angles are congruent to the same angle, they must be congruent to each other. All right, and remember, you might stink at proofs, but you should never mess up the last statement. It's always what we're setting out to prove. Line A is parallel to line C. How do we know that? Well, since 1 and 3 are congruent, the lines are parallel by the alternate exterior angles converse. All right, and why is this a converse? Stating lines parallel. Okay, so that's a good proof. We got to see the difference between a theorem and a converse in the same proof. We prove that two lines are parallel because they're parallel to the same line, so on and so forth. We're going to finish these notes in the next video.